Greetings everyone, my name is Anmol Pandya and I will be presenting our project Decentralized Voting System. First, I will introduce the concept of a decentralized voting system and then we will discuss our motivation for choosing this topic, especially as the government is promoting the One Nation One Vote initiative, which aligns well with our project's objectives. So let's start with the introduction. A decentralized voting system leverages blockchain technology to make the voting process more secure, transparent, and accessible. Unlike traditional voting systems, where centralized authorities manage the voting infrastructure, a decentralized system distributes control across multiple nodes. Each vote is recorded on a blockchain which is immutable, meaning that once data is added, it cannot be changed or tampered with. This approach minimizes fraud, enhances transparency, and ensures that each vote counts without external interference. With the increasing digitalization of services, the need for a secure and reliable voting system has never been more crucial. Now let's discuss why we chose this topic. Our interest in the decentralized voting system is driven by the government's One Nation, One Election initiative, which aims to streamline and unify the voting process across the country. This initiative highlights the need for a voting system that can handle vast numbers of votes in a secure and efficient manner. A decentralized voting system aligns well with this vision, as it offers a scalable and transparent solution that can serve large populations. By exploring this topic, we aim to contribute to the ongoing discourse on modernizing election process and improving the democratic participation. Now let's take a look inside our project setup. First is front end. The front end is fully developed in React and we have used various modules or libraries. We have used routers in main.jsx for connecting the various components of pages to the portal. Now we can see the component folder where all our components are present. There are three components: the starting page, the login page, and the voting main.jsx. Let's see the starting page, which consists of one button for the user, and when we hover onto it, it changes to Ashok Chakra. After clicking on this button, it takes us to the login page. Login page consists of a form that is needed to be filled by the user. Here we need to take user information like user's full name, one photo identification which they can choose from the given options, and at last there is an identification number. All the information is saved on our Mongo database system, and the last part is the voting main.jsx, which is the main part where the actual voting occurs. Here we have connected our smart contract with the front end using the Web3 library, and we have created a way through which the user is prompted to log into their MetaMask account, and now they can select any one party out of three to vote. There is also a gas estimator which shows us how gas money would be required for voting. Now let's take a look inside the backend of our system, which is created using Express and Node.js. Here we can see the index.js file. Here exists all the information about connection to MongoDB and how we are sending post requests to the database. Here we can see what type of information is being stored. Here we can see Multi library, which is used for handling multi-part form data, which is used for taking photos and PDF files. We will be soon adding a live photo comparison system which compares the photo from the user provided document and image taken during the sign-in process, and then we will compare them to make sure that the voting process is clean and secure then after. Here we have implemented a function which checks for whether the user has already voted or not, which takes us to the end of our backend. Next up, we have to consider smart contract, which is created using Solidity, which is based on Ethereum blockchain. Here we are only storing user wallet's public key and user has voted to which party. The contract is compiled through Truffle and we are using Ganache for backtest, which helps us to simulate a real-world Ethereum transaction. At last, let's turn our attention to the final output. Here is the starting page, and after clicking we can see the login page. I will enter all the details, and after that we can see the voting page. We are prompted to connect to this page, and after clicking on the vote button, we are prompted by MetaMask to pay for the gas money. After paying, we are shown the party which we have voted and return to the home button. Let us see the transaction detail in Ganache. Here we can see the user has voted to which party. Thank you for your attention, and I hope that this gave you valuable insights about the topic and our project.